So, hi, I am Shubham Singh and I will be presenting my assignment 2 of CML 102. So, basically, we have to solve and refine the crystal structure using the OLX software, and also we have to make a crystal packing diagram using the Vesta. And using Vesta, also, we have to do the powder diffraction pattern of the given crystal data. So first are some general instruction about the OLEX software. So like OLEX is a advanced software for solving and refining the crystal X-ray diffraction pattern. We used to visualize it and also draw the crystal backing structure. So there are some general steps like for first the data preparation. We have given the two files .hkl and .ins files. So basically we have to first import the files into the our uh, OLX2 directory and using we have also used the shell X tool in OLX to solve the crystal structure. We have verified this and solved the to ensure the correct uh, atomic structure. Then we have refined the data using the OLX. We have to make to get proper R factor values. Also, we cross checked by the number of hydrogen atoms on each atom there. So these are some general instructions for all the given data points. Now we are moving to particular steps for each data point. Like the first structure we are given of the hydrochlorothiazide. Hydrochlorothiazide. So let me first hydrochlorothiazide. So this is the structure of hydrochlorothiazide. Based on this, we are given the electron density from the data. The try to we will try to draw this structure and get the atoms by the electron density data. So there is a so some general instructions are like first like we have to first find the planar structure diagram of the so like for the first hydrothioionized data, find the planar electron density for the 6 carbon chain of the hydrochlorothiazide and assign the 6 carbon accordingly. Identify the 6 carbon ring attached to the carbon ring. This carbon ring contains sulfur and nitrogen. Distinguish between this using the electron density, as sulfur has higher electron density than the oxygen atom. So basically, this is the 6 carbon chain we are talking about, and this is another 6 carbon chain having sulfur and nitrogen. So this is nitrogen, the blue colored one, and this is sulfur. The We will distinguish by that sulfur has more electron density around it because of the oxygen atoms attached to it. So this is basically we are going to draw the structure of thiazide. On the other side of the carbon, locate the sulfur atom attached to the two carbon sulfur, identified by the electron density with the NH2 group attached with the sulfur. So on the other side, we will have to draw the sulfur, double bonded O, then NH2 group attached to it. And then we will, so now let me show you like by adding hydrogen, these hydrogens like the software will detect the hydrogen atoms and assign accordingly. But by default, it will draw three hydrogen atoms like here nitrogen. But we know that the nitrogen has only two hydrogens. The one extra hydrogen the software is attaching is maybe due to the electron lone pair attached present of the nitrogen. So there is an extra electron density adding to it. Refine the structure. So we are basically refining the structure at each step using this like refine tool. Uh, and so after refining, we are getting an R factor of 3.76, which is less than 5 and which is closer to our observed data value. So it is good. So this is basically the structure of the hydrochlorothiazide. Now we are moving to the second structure, uh, which is rulizole and malonic acid. So what is the structure? First, we will identify the rulizole. So this is the structure of rulizole. So in this also we will identify a center carbon chain, six carbon chain attached to a five-member carbon chain, a five-member ring. So in which one has nitrogen and one has sulfur. So we will try to identify it, and uh, the carbon is attached to the NH2 group and nitrogen is present here. So, and on the other side of the ring there will be oxygen attached to carbon, and carbon is sp3 having three attached to three fluorine atoms. So the same steps I have written here also, all this, but like nitrogen is a five-member ring, will initially get a hydrogen atom. Like when we, sorry, when we attach hydrogen. So this is the structure we have drawn. So this. So initially the nitrogen will get attached to one hydrogen also, but we know that this is due to the lone pair present on nitrogen. So this electron density is maybe due to the lone pair attached to it. So we will try to avoid the hydrogen atom attaching here. And this is the structure of malonic acid, in which we have three carbon, uh, and the other two carbons are basically the carboxyl group, carboxylic acid, and there is hydrogen bonding present there also. So this is the structure of rubizole plus malonic acid. Now our third structure. Third structure is of ruluzole and orthophosphoric acid. Ruluzole and orthophosphoric acid. So we have to first draw the same. So basically, we have to draw the same steps for the ruluzole, but for orthophosphoric acid, there will be. Let me first open it. So this is the structure diagram of the phosphoric acid. So the carbon or phosphoric acid salt. So basically, this central atom is phosphorus. This is oxygen, 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 and these two oxygens are attached to hydrogen, and there is a hydrogen bonding between these also. So we are basically getting an R factor of 3.31, which is much less than 5, and we are close to the observed value here also. Uh, Now our second task is to draw the crystal packing diagram using the Vesta. So we will, so uh, here also, like refine in the refine part, there is a, let me first click on downward arrow. There is this arrow. So we have to select the acta, and there is CIF files will be generated. These CIF files we will open in Vesta to draw the crystal packing diagram, to get the crystal packing diagram. So like let me first do the hydrochlorothiazole. So this is the crystal packing diagram we are getting from it. So we can see there is a we observed there is a hydrogen bonding between the oxygen attached to sulfur and the hydrogen attached to nitrogen. So basically, there is hydrogen bonding between the hydrogen attached to nitrogen and the oxygen attached to sulfur. This you can see clearly see it. In the second data, we are getting the there is an internal hydrogen bonding in the malonic acid. Basically, it is a double carboxylic acid group. So there is a hydrogen bonding between them, and a hydrogen bonding between the hydrogen of the NH2 group and the oxygen of the malonic acid. So there is also a hydrogen bonding present there. Let me first draw it. First get it. There is a hydrogen bonding present between hydrogen of the NH2 group and oxygen of the malonic acid. This. Similarly, for our third structure, there is a hydrogen of the NH2 group of the five-member ring of riluzole and the oxygen of the orthophosphoric acid. So there is hydrogen bonding also present there. We can also open it and see there is hydrogen bonding present. So using the crystal packing diagram, we get to know about the hydrogen bonding present there, about the different atoms, and also the packing structure we can get. So our third task is to powder XRD pattern stimulation. So basically, when we have opened it in Vesta, and we can go to utilities, and then click on powder diffraction pattern, and it will draw the powder diffraction pattern of the provided data, provided structure. Based on the atoms present, they have particular data of the what are the powder diffraction data of the particular atoms. So based on that, software will draw it. So let me quickly go. So we are observing the peaks in like our first data set also, second data set also, third data set also. So the presence of sharp and well-defined peaks indicate that these are in crystalline form, not in the amorphous form. Because in amorphous form, we are in broad featureless diffraction pattern, like a broad, there is no peak. So the given diffraction pattern can also be compared to some reference databases like International Center for Diffraction Data to identify the this drug is particularly like it is original or it has some mixture of other materials. So it is we can get to know that it has its polymorph or not. So what is the conclusion? Through the assignment, the crystal structure for the three datasets were successfully solved and refined using the OLEX2 crystal packing diagram and stimulated PXRD patterns like the powder diffraction pattern were created to illustrate and validate the results. This study highlighted the importance of structural refining and visualization techniques in understanding the molecular structure. Crystal packing diagram. So I will be basically attaching the all the three data sets of the my like OLX2 software and Vesta also. So I will providing all the attaching all the attaching all the files here, and also the video I have created. I will attach the link to it also. So thank you. And